I am very happy to introduce Manuel, the Director of Marketing at Ettus Research.
All right, thanks, Ben. Sounds like this thing's on. Great, okay, so yeah, as Ben said, my name is Manuel. For those of you who don't know me, as one of my other jobs as Chair of the Board of Directors of the Wireless Innovation Forum, I've been in the SDR community for over 20 years now. Now, one of the things I realized with the title of this presentation is it's incredibly vague. In fact, you could make the argument that it sucks. And I would accept that criticism. Part of the problem with that, of course, was I didn't finish my presentation until Friday, actually, honestly, about 15 minutes ago. And I had to have a title in like weeks ago. So I was intentionally being quite vague. But I looked at some of the titles on the program, things like opening that which is closed. I'm still, like, my brain is still blowing up over that one. That's an awesome one. I want to see that one. There was one like finding an active shooter using GNU radio. I'm just imagining this whole room running around with B210s. Finding the shooter when in fact they actually should be running in the direction furthest away from the shooter as fast as they can. So anyway, I will try to come up with a better title for next year. It may sound something like this for those of you who know Matt Ettus. If this shit was easy, everyone else would already be doing it. That seems like a pretty good title. May or may not use it for next year, but I'll try to come up with something better. Now, what I did want to start out with was actually talking about the RFNOC Avato HLS challenge. So for those of you who are here, figuratively, last year, Matt Ettus announced this challenge along with Xilinx, and the whole idea was bringing together two seemingly pretty cool and useful technologies, right? Xilinx's Avato HLS, which allows you to target algorithms written in C or C++ to an FPGA, not the easiest thing in the world, and RFNOC, a tool that allows FPGA developers to integrate IP into their usurp design flow. And that was the intent of the challenge. I think the good news is at this point, with the challenge having just completed, we can say it works, right? There are teams that have successfully done it. That work is all open source. It's available on the Xilinx GitHub, and I recommend you go check it out, see if you can use it in a project. And we did announce 3 winners. Third prize went to Team WinLab, which was from Rutgers for their real-time wideband channel sounder. The second prize actually is a local team, Team Rabbit Ears. I don't know if there's anyone here from Team Rabbit Ears. There we go. Okay, so Team Rabbit Ears for their ATSC signal processing library, they actually put through a lot of blocks through that whole flow from Avato HLS to RFNOC, including a Viterbi decoder. So definitely worth talking to them more about that. And first prize, which was actually a pretty good prize, I thought, $10,000 grand prize, was Team E to the J Omega for its neural network library. And EJ is actually here to accept the prize. So come on up, EJ. So a little shout out to EJ. His presentation is Tuesday at 3:45 p.m. So please come and listen to his presentation. It's cool stuff. It's all open source, and he's $10,000 richer for it. So EJ, congratulations. Congratulations. Nice job. I did ask if I could get one of those big checks, and I was told no, but I tried. I think that would have been really cool. Okay, so my title had something to do about future directions, so okay, let's talk about the future now. So what does the future hold for COTS software-defined radios? So there's a lot of vectors that one could take around the future, right? So let's do kind of polling as we go through this slide. So first of all, frequency coverage. Well, I think it's safe to say from a COTS perspective, sub 6 gigahertz is pretty well covered, right? So my question would be, does anyone here in the room need more frequency coverage than that? Okay, not a surprise. Quite a few, actually less than I expected, but still quite a few people. And there's a lot of things driving that. You might have applications that involve radar. You might have applications that are involved with 5G, right? So as 5G moves to millimeter wave, we're now looking at 28 gigahertz, 39 gigahertz. There's unlicensed frequency bands at 70 gigahertz. So I think that's fair. Frequency coverage and expansion of frequency coverage does seem like a very relevant way to try to move the bar on the future of COTS SDRs. Okay, so that's one. More channels. Okay, who here thinks they need more channels from their SDRs? Okay, quite a few people. So this one's an interesting one. At Ettus, we have university customers that have built 128 antenna massive MIMO systems. Paul Tillman was here last year speaking about the DARPA Spectrum Collaboration Challenge, where we worked with them to build a 256 by 256 channel emulator. And so that kind of brings in the topic of scalability. And I would argue that that's actually pretty darn good. I don't know how many more channels you'd really want. But I could see folks that, for example, in their one software-defined radio, instead of having, say, 2 channels, might want to be able to do 4x4 MIMO or 8x8 MIMO. I think that's a very legitimate use case. So I think this is one that warrants some further consideration. All right, more bandwidth. This is an interesting one. So 160 megahertz of bandwidth is quite a lot of bandwidth. Who here needs more bandwidth out of their SDRs? It's the same people putting up their hands every time. I don't know why. I want to talk to you guys offline and figure out what you're doing. Okay, so bandwidth is another interesting one. So 100 megahertz and 60 megahertz is a lot of bandwidth. If you look at applications like 5G, you look at military comms, that's plenty for the moment. But again, you start looking at things like 5G. Okay, at millimeter wave, you want as much bandwidth that you can exploit as possible. 400 to 800 megahertz of bandwidth is roughly where the discussions have been around, and they seem to be coalescing now around 400 megahertz of bandwidth. So again, there seems to be a very solid use case behind having more bandwidth in a software-defined radio. Okay? More compute resources. Who wants more compute resources for their SDR? I actually expected everyone to put their hand up. I think some of you are just shy. Maybe it's too early in the morning. Most people want more compute resources. Unlimited would be great. That's great as long as your wallet is also unlimited. Then it's no problem at all. So, again, there's trade-offs to be made here. More compute resources can always be provided, but at an increase in price, right? So what's that trade-off? Okay, lower size, weight, and power. Do I even need to ask? I will ask. Okay, who wants smaller radios? Yeah, now everyone's putting their hand up. Okay, yeah, as to be expected. So totally understand, totally get it. There are some challenges with that again. It's not really fair to come say, hey guys, we need 512 antennas and I need it in a box this size. Okay, well that's nice. We can't really do anything about that. So size, weight, and power we know is very important. And within the constraints of certain number of antennas, absolutely also seems to be a very legitimate and valid case for that. Okay, what about lower latency? Who here would like lower latency? Okay, yep, quite a few people. I think that's also not a surprise. So you look at things like Wi-Fi. Okay, beacon response time. That's tough. That's a challenge to meet that kind of latency. In things like radar, military communications, again, latency, very important. And again, you start looking at 5G. The TTI for LTE, the time transmission interval, is 1 millisecond right now. It's going to go down to 0.5, eventually down to 0.25. That's going to be hard. That's going to be hard to meet. So latency is definitely a pressing issue, and I think that one needs to be addressed at some point. Okay, what about more accurate synchronization? Okay, yeah, actually I got more on that one than I was kind of expecting. So that's an interesting one. There's certainly a requirement for synchronization, phase coherency for many types of systems. The accuracy has always been an issue, but as systems get lower in latency, it becomes harder to synchronize, right? So there's trade-offs that have to be made there. And you also have in the military things like, okay, you have to be able to operate in GPS-denied environments. Okay, so those are all things that, again, we end up having to trade off against some of the other things on this list. Okay, more applications. Who wants more applications? Seriously, Bob's the only guy that wants more applications? Are you guys for real? Okay, yeah. I kind of thought everyone would have their hand up for this one. The number of needs that are popping up every day for software-defined radio and cognitive radio are only increasing. So I think everyone wants more applications to get a leg up, to get further ahead in the actual place where they're trying to add value around their algorithms. One of the issues that I see with applications is it's really tough to monetize. Right? So I worked at Xilinx for many years. The FPGA IP ecosystem, it's treacherous waters, right? Because as a third-party IP company, you can develop IP. It can be the greatest thing since sliced bread. You can charge for it, great. And then maybe 6 months later, Xilinx or Altera come out with roughly the same type of IP. And how much do they charge for that IP? Virtually free, right? If you buy enough chips, it's for sure free, right? I mean, I worked there, I know. So there's a business model issue around applications, and that's one that I don't know that I have a great answer for. I think there are ways that problem can be solved, And there is a small ecosystem, but how do we make that bigger? I think that's an interesting challenge. Tools. Okay, who wants tools to make their life easier? Okay, there are some people here who like to do things the hard way. I'm going to note that. We can easily solve that problem. We'll just remove all the documentation, Martin, for the next release of UHD. Just for them. You got the ones that, yeah, okay. So again, I kind of thought everyone would have their hand up for this. Tools to make life easier is always seen as a good thing. One of the issues are, of course, what tool do you want? Most people here are going to have a different answer. How would you like it implemented to solve your particular problem? Most people are also going to have a different answer. And so this one also becomes very, very challenging and very tough. I think it also takes a whole ecosystem to develop this particular vector. I do think there are tools like Avato HLS that solves a problem around targeting FPGAs and making it easier for folks that are conversant in C, C++, like most of the folks in this room. But that would be an area that I think is ripe for innovation, but again, can also be tough to monetize and tough to come up with an implementation that can actually be useful and well used. And the other point I would make about tools, actually, and this comes back to languages, if you have to educate the entire customer base, you are dead, right? So I think that's just exceptionally hard to do, and no matter how good the technology is, it's really hard to do that. Okay, this is an interesting one. Who here wants more regulation? All right, this is exactly what one person. Okay, was that Dan? I wanted you to give me, something to work with there. It surprised me, but I was willing to go with that. Okay, so regulation is kind of like taxes, right? So who wants more? Nobody. And that's fair. I do think, however, that there are more regulations and more policies coming down the line, and it's not necessarily a bad thing. Okay, so you look at things like CBRS, the Citizens Broadband Radio Service, which is essentially 3.5 gigahertz for LTE services that have to be shared with naval radar. Okay, do you think we have to have regulations and policies to do that properly? Yeah, definitely. Do you think the naval folks would be pissed if their AESA extremely expensive aircraft carrier radars stopped working along the coastline? I think they might have a problem with that. So, whether we like it or not, it's coming. Spectrum management is changing from exclusive licensed usage to more open spectrum sharing, unlicensed usage, which I think most people in the room think is a good thing. I know I do. But again, that's going to come with some more regulations and policies. And I think those are all things that are manageable. We just need to be aware that they're coming and figure out for our SDRs, how do we add the intelligence, the policy engines to make that all happen and work well. Okay, we talked about cybersecurity. Is anyone here concerned about security? Okay, is anyone here concerned about security because it makes them harder for them to hack things? It's the same people. I knew it. It was the same people. I knew it was, yeah. All right, so I think everyone realizes the importance of security. I think, IoT visions of light bulbs with Wi-Fi, okay, great, but, when they're unsecure, maybe not so great. Being able to hack a Jeep doesn't seem like a great thing to me, especially when you're driving in said Jeep and it's being hacked while you're driving it. So security seems like one that, yeah, that's probably one we need to find a way to address, right? What about reliability? Who wants more reliable software-defined radios? Okay, quite a few people put up their hands. No surprise. So my question would be, what is more reliability? What does that mean? What's the metric? How do you measure it? What would we do to prove to you that a radio is more reliable than another radio? It's not that easy, actually. There are metrics like MTBF. I would argue to you that MTBF is virtually meaningless. You're going to ask, we'll give you a number. It's just very theoretical, right? So unless you actually put these things and tested them through various environmental considerations, basically the type of environment and operating conditions that you would have for your application, you can't really make a good argument about reliability. That's a tough one. So that's one that there are some struggles around how do you make the hardware more reliable, but there are ways in software, I think, that those things can be addressed to make your lives easier, to make the radios easier to use and more reliable from a network sense. So when we look at all these things, again, there's trade-offs. You can't have it all, sorry. We'll do our best, but you can't have it all. From the Ettus perspective, we've certainly had to make choices. We've had to make trade-offs. We did that with a lot of feedback from a lot of customers. In fact, many of you in this room today, so I thank you for that feedback. And we took as many of it in and took it to heart as we could and tried to come out with some new exciting products that meet as many of the key priority features as we thought we could. And so what does the future hold for USRP? Well, I would like to introduce today officially the Ettus USRP N310. There's also an N300, which follows the big FPGA, small FPGA convention. So as we go through this, you're going to start to see, okay, what trade-offs did we make? Which one of those features did we go for? Which one of those did we accept that we were going to have to give up, right? So I find it really ironic, having been in the SDR industry for over 20 years. It's called software-defined radio, and the first thing we always talk about is the hardware. I find that incredibly ironic, and so what better than to talk about the hardware first, right? But we should always remember it's called software-defined radio. Okay, so let's look at this N300 family motherboard. Okay, you'll see that there is a Xilinx Zinc FPGA on there. Okay, that's cool. It gives you some embedded standalone capability. Okay. You can see, and again, like I said, there's a large FPGA and a small FPGA variant. There are daughter board connectors, just like we have on the X310 and N210. Memory is obviously important, Ethernet. You'll see there's 2 SFP plus ports. Okay, so high streaming bandwidth, clearly a priority, right? Throughput to be able to get the data to the host. USB and JTAG for debugging and control. Okay, so yeah, let's stick with the hardware theme. Yes, more hardware. We didn't talk about the daughter boards. So daughter boards, with the N300, there will be 1 daughter board. With the N310, there'll be 2 daughter boards. Each of those daughter boards has on there an ADI 9371, so otherwise known as Mykonos, for those of you familiar with the chipset. Very capable RFIC, 100 megahertz bandwidth. And so you have the ability to do either 2x2 or 4x4. Okay, so we talked about channels earlier. 4x4 is a step up. Okay, that's one of the trade-offs that we were willing to fight for to make happen. And the ADI RFIC was definitely the key enabling technology to help us make that happen. Okay, really, can you believe we're still talking about hardware? I actually just threw this in because it's kind of a cool picture, but it just kind of shows how it all comes together. There will be 2 variants, as we've had traditionally. There will be an Ettus branded variant called the N310 or N300 that will support UHD, RFNOC, and GNU radio right out of the box. And then post-release, we'll also have the MathWorks support on the Ettus branded. And then there's the NI branded, which will be called the USRP 2971 or 2970 for the smaller FPGA, and that will have LabVIEW support for, I think, the 2 people in here that use LabVIEW. So yeah, it's for you, Daniel. Okay, so getting kind of sick of hardware, right? But you know, we might as well stick with the theme. There are some key RF performance specifications. So, oh, is there a question already? Yeah, so the question is this an ultra-scale Zinc, or is this just a regular run-of-the-mill Zinc? And the answer is it's a regular run-of-the-mill Zinc. Ultra-scale Zinc is something that is certainly in the future, but not today. So up to 4x4 channels, 4RX and TX. ADCs at 16-bit resolution, DACs at 14 bits resolution, 100 megahertz of bandwidth, so not the widest that we have in our portfolio, but you know, the Mykonos was basically targeted for LTE microcells, so 100 megahertz is ostensibly the largest bandwidth you'd need for 5 by 20 megahertz carrier aggregation. It is meant to be phase coherent, so you can do all your direction finding applications, massive MIMO. Typical frequency coverage, 10 megahertz to 6 gigahertz. So Mykonos itself is 300 megahertz to 6 gigahertz. We added the block up and down converter so we can get down to 10 megahertz. We are adding IQ impairment corrections, so that's actually a nice addition. IQ sampling with IQ imbalance, as well as DC offset calibration. We had a lot of requests for that in the past. And programmable FIR filters. Okay, it's about time we talk about software, right? So it's software-defined radio. Let's talk about software. So I talked a little earlier about reliability, and this is a way that I think we start to address it. And actually, for me, personally, this is the most exciting part of the N300 family. It's the software. And Martin, by the way, is going to be talking more about that in his talk on Thursday, so I encourage you to come listen to his talk. But we're adding things like the ability to do remote firmware and OS updates, remote reboot, being able to reset it to the factory default settings remotely, as well as do remote diagnostics, including system health. So from a network perspective, that gives you reliability. It gives you an ability to manage the network, to not have to do a truck roll every time a device goes down. I think that's pretty awesome, and I'm really looking forward to seeing that out in the field. We'll also have watchdog timer, quadrature and DC corrections I talked about. Okay, and the other thing I talked about was security, right? Okay, so we've added a trusted platform module, right? So that gives you an ability to create a root of trust on the device, right? So you can do secure boot, do encryption, decryption. So again, security, yep, check, got that one. And yay, more software. Essentially, the ability here is to be able to run in two modes. One is embedded mode, so again, running with the Zinc. Yes, it is dual ARM Cortex A9s. It's not the quad-core A53s. So there will be some limitations in terms of compute resources on the GPP side. But again, those are things that you'll have to consider as you architect your application if you want to run this in standalone mode. And then there's network mode where you just stream straight to the host computer and you have the SFP Plus connectors to do that.
Does it stream like full speed, like an X series?
Yep.
Or do you end up hitting the limitations you hit like the E series where you can't send the full bandwidth?
Right, so the question was, can you stream the full bandwidth or do you hit limitations? And the answer is yes, you can stream the full bandwidth with the two Mykonos daughter boards. Yeah, so that was the intention. In terms of applications, as you might have guessed from the earlier conversation, communication systems design is absolutely one of the target areas, so 5G new radio, LTE, Wi-Fi, being used for UE emulation, right? For most UEs, the ARM Cortex A9s are sufficient processing capability. Massive MIMO is a target with the additional channel count. We believe there's great applications for SIGINT and comment and ELINT, as well as electronic attack. Spectrum monitoring, navigation, record and playback, and a million other things that people will think about that's really cool that we haven't thought about. And you can see availability is in Q1 2018, so early next year, and that's with UHD, RFNOC, and GNU Radio. And again, like I said before, LabVIEW Communications and MATLAB will be post-release. Okay, one of the other things I talked about before was synchronization. Okay, and there were actually quite a few people that wanted more accurate synchronization. Has anyone here heard of White Rabbit? And not as a magic trick. Okay, quite a few people have heard about it. Okay, very good. If you look in the commercial space, there's a standard called CPRI, which is a very common standard. There's actually multiple of them, but CPRI is one of the more commonly implemented ones. Ironically, although it stands for Common Public Radio Interface, the common is not actually implemented commonly across vendors. So there are some issues with CPRI. There are many folks in the telecom world that want to move to IEEE 1588 for PTP and synchronous Ethernet to replace CPRI, and that's a pretty viable way to do it, I think. White Rabbit is kind of like 1588 and synchronous Ethernet on steroids. So it gives you even better accuracy than you will get with traditional 1588 and synchronous Ethernet. And so that was really appealing. It still gives you the ability over fiber to support long distances, about 10 kilometers, and the ability to scale up. We talked about scalability before, so scaling up to 2,000 nodes. Okay, so that's the end of the N300 family discussion. So moving on, what's wrong with this picture? Oh, someone actually, okay, yeah.
You add additional oscillators on the baseboard itself for White Rabbit?
Oh, going back to the White Rabbit. Yeah, so it'll be a combination of having to use our hardware with some additional external third-party hardware. Okay, so to answer this question, which was kind of rhetorical, there is nothing wrong with that picture. We love the III10. It's a great product. Everyone's probably trying to stare really hard at the writing to see if there's some kind of mix-up there. Now, the better question is probably, what could be better about this picture? So, all right, let's go back to hardware, right? Because we do software-defined radio, so we talk about the hardware. So I don't expect any of you to read this. Go for it if you want to. But for those of you that are very observant, you might notice in the bottom right corner something called a USERP E320. Okay, interesting. And in the middle, in big writing, so obviously you're meant to read that, you see that there's a larger Xilinx sync, a 7045, sorry. And so what does that mean? Well, for those of you who are coming to the obvious conclusion, E310 with a larger FPGA, yes, that is exactly what that means. So we're also announcing today the USERP E320. The E320 has, like I mentioned, the larger Zinc, the 7045, so you have a lot more processing capability in an embedded format. It also adds, we talked about throughput, and someone asked a great question about that. We've also added an SFP Plus connector. Okay, so now you don't have limitations on the streaming throughput out of the E320 like you had with the E310. Okay, so we've solved that issue. TPM, added that in there. So again, security, got it. And you know, at the end of the day, swap is really important, and we understand that. However, in order to accommodate all of these additional features, we had to give on something, and that was one of them. So the form factor is a little larger. It's essentially 3U Eurocard form factor. Okay, last couple slides. FPGA resources comparison. So you can see the E310 fits pretty much right in the middle of our portfolio. It actually gives you quite a lot of resources to use in embedded capabilities. So we think it's going to be a real winner. I talked about most of this already, but there will be also an enclosure that acts as a passive heatsink. There'll be a header to add a fan, and there will also be temperature sensors, so that will also help with the reliability. And to help with portability, there'll be a connector so you can excuse me, add a battery, and specifically the battery of your choice of however large you need it to be for your application, unlike the E312. All right, so that's it for this morning. I did want to draw some attention to some of the other Ettus events this week. Like I mentioned, the Thursday Speak for Martin Brown will talk about more on the future of the software side. I think that'll be really interesting. There's an RFNOC tutorial that has Neil and Nate giving that on Wednesday and Friday afternoon. You do need to sign up for that one if you want to attend that. There are 3 lightning talks on Friday from Tom Su, Brent Stapleton, and Neil Pandea. And then Marcus Mueller is giving a talk on debugging GNU Radio applications on Wednesday. And finally, starting tomorrow at noon, we'll have the Ettus booth open, live demos galore, including an N310 demoing and actually running. So look for us, the whole Ettus gang, in green. Thank you.
All right, we've got a couple minutes before our break. Are there any questions? Tim. Tim is asking about the price.
Come talk to me later. Yeah, no, we cannot publicly announce the price before we actually have it available. So yeah, come talk to me later if you have a particular program that you need a price on.
Other questions? Jose, perfect.
I don't know if you can know at the moment, but the performance difference between the Twinrix current card versus the Mykonos?
Yeah, so
dynamic range.
ADI's in the room, so I have to be circumspect about what I say. But I think I can make the comment. TwinRX as a superhet receiver is just going to give you significantly better performance than a direct conversion. That's just physics. It's the reality. Mykonos is a very good RF IC for what it's designed for, LTE microcells.
Any other questions? Right here.
What's in store for the future of UHD?
Oh, what's in store for the future of UHD? So I get to defer that one to Martin. Thursday. His talk is Thursday at 11:15 a.m. So please come to that talk. He will go through it in much more detail around the specifics around UHD, as well as the additional remote management features that we've added.
Other questions? Nope. All right, let's thank Manuel.
Thanks,
Thank you
everyone.
very much. Thanks, man. All right, so we're now at a 15-minute break. At the end of the break, we will resume with Matt and Mark giving their cybersecurity talk. If you guys can come up and set up whenever you like. Please remember, if you do want to leave, you can get out stairs and elevators that side, stairs and elevators there, stairs there, and there are drinks and refreshments in the back.